Okay, so we're going to review our properties of exponents. This will be really important for this unit and the next unit that we do. Hopefully you remember several of these from Math 1 and Math 2. But does anybody know what anything to the 0 power is? It is 1. That's it. Anything to the 0 power is 1. If you ever get confused about that, you can type it in your calculator. Pick any number that you want, put it to the 0 power, and you get out 1. What about x to the 5th times x to the 2nd? X to the 7th. That's right, we do add them. If you remember how exponents work, x to the 5th is multiplying x by itself 5 times, and then x squared would be multiplying 2 more times. So total we have 7. So we add those exponents together. What about if we have x to the 3rd, then to the 2nd? X to the 6th. That's right, we multiply. When you have something raised to that power, you kind of start with the outside power first. So that would be x to the 3rd times x to the 3rd, or we would have 3 x's times 3 more x's. So total, we have x to the 6th power. There's a little song that goes along with these. Y'all like songs? As we cry. So it's kind of to that tune, if you're happy and you know it, because we're all happy to be in math. Not today, we're all tired. All right, but it goes, anything to the 0 powers 1. Anything to the 0 powers 1. If you have a 0 power, you should sing a little louder, because anything to the 0 powers. Not 2. All right, then this one is a power times a power, so I add. Power times power, so I add. 5 power times power. I should sing a little louder because a power times a power, so I. There you go. And this one is power to a power multiply. And this one is a product to a power. What does the word product mean? It's a multiplication problem. Now notice this is multiplying. If you read this, it would be 2a to the 3rd, but the implication there is multiply because we're doing 2 times a to the 3rd. If you have a product to a power, you share the power, okay? It would share with anything that's written on your notebook paper line, so any big numbers, not the exponents. So this is really 2 to the 4th, and then a to the 3rd to the 4th. Now, what is 2 to the 4th power? Not quite 8. 16, because it's really 2 times 2 times 2 times 2. So it ends up being 16. Don't forget, you can use those handy dandy calculators too. I almost had to type it in. And then what is 3 times 4? 12. Now, when in doubt, write it out. So if this is to the 4th power, it means that you can multiply this by itself 4 times. I'm just going to go this way so that way I don't run out of too much room. Do one more. So if you multiply it by itself 4 times, you can see the 2 times the 2 times the 2 times the 2, which ends up being our 16. So when in doubt, write it out. All right, let's sing one more song. If there's a power over a power, you subtract. That's right. Now, how I remember to do these is I subtract the bigger number from the smaller number and put my answer wherever that bigger number is. So what's 3 minus 2? 1. Do we usually put things to the 1st power? No. So if you leave that off, that's okay. And most people like to subtract the top from the bottom. Now, when in doubt, write it out. So it's 3 of the x's on top and 2 on the bottom, and we could cancel out things that are alike. So these could go away and those could go away. So we're left with just 1 x that's in our numerator. Now let's do the same thing with this one. Power over a power, we subtract. Now when you subtract top to bottom, you get a negative number, which brings us to this next one. Does anybody know what we do with negative numbers? Well, negative numbers are not happy, right? Think about negative people. They're sad. So to make them happy, you move them. So you move that negative exponent and change it into a fraction. So a negative exponent moves to the denominator. Good, it becomes a positive exponent. So in the top, we would just have a 1. So this one up here could work that same way. 6 minus 10 is -4, and then you could write it. Or a little shortcut that I like to use is subtract them biggest from smallest, put the answer where the bigger exponent is. So we subtract these, we get 4. So I'm going to put y to the 4th in the bottom because that's where the bigger answer, bigger number is. And then we would just put a 1 on top. Now what's wrong with this last one? It's on the bottom, so what do we need to do? Flip it. Yep, we just take that term and we move it to the top. And then would we have anything in our denominator now? No, you could put a 1 if you wanted to, or just leave it as a to the 5th. So if you have multiple exponents, which you'll see in just a minute, only move the one with the negative exponent. I told a little story one time. When negative exponents, they're kind of unhappy. So like this last problem, this little guy's living in the basement. He's not very excited to live in the basement by himself, so he moves upstairs, and there he's happy again. Well, this person lives upstairs, this x to the -2, and it wants to move to the basement for some peace and quiet. So it moves to the basement. Look there, it's happy again. So if you see a negative exponent, you make it positive by moving it. Move it to the top or the bottom, whichever one you need to. All right, let's practice some of these. So write these down just one at a time as we go through them. So just write down the first one. We went through those rules, and now we're going to do some application problems. Now, as we do these, you can only combine things that are alike. What makes these alike now? The bases, the x's are alike, the y's are alike. Good. So when you do this problem, this x to the 3rd would combine with this x, and then the y to the 5th would combine with y to the 4th. So you can only combine those things that are alike. So what is x to the 3rd, y to the 5th times xy to the 4th? Good. X to the 4th, y to the 9th. If there's a power times a power, so I add. Thank you, Carter. Which way I want to go? Up and down or left and right? Left or right. Okay. So let's do this next one. I should probably label these. So problem number 1. Okay, these are now power over power. If there's a power over power, you subtract. Normally, when I see a fraction, I go ahead and make a fraction bar. And then look at those common letters. There's some A's there. A to the 7th over A to the 5th makes, where would A to the 2nd be? On the top, because that's where our bigger exponent is, right? So 7 minus 5 is 2. Put it in the top. What about b to the 3rd over b to the 5th? It would be b to the -2 power, or you could say b to the +2 power if you put it where? Where's the bigger exponent? On the bottom. So put your answer where that bigger exponent is, and don't worry about the negative. Some people might write it this way, a to the 2nd, b to the -2nd. But one thing that you can't have in math are negative exponents. You got to get rid of them. That's one of the math commandments over there. The first one is thou shalt not divide by 0. And somewhere down the line is thou shalt not leave a negative in thy exponent. Makes it sound more official with the thous and theys. So make sure negative exponents are moved. So it's just the b that moves to the bottom, not both. All right. Write down problem 3. What can we do with that exponent? It's like we distribute it. We share it. If there's a product to a power, you share it. So everything gets shared. If you don't like to share it, though, write it as many times as it's there. If something is to the third power, that means you're multiplying that thing 3 times. So that's another way, when in doubt, write it out. Or you can share it. So either way is fine with me. Now, what happens to negative 3 to the third power? Well, that's negative 3 times negative 3, which is 9, times negative 3 again, negative 27. X to the third, y to the 6. If you're using your calculator, you can't type it in with the variables, but you could type it in with the numbers. You have to make sure your number is always in parentheses and that exponent is on the outside. So that gives us a negative 27. Remember how it works when we have a squared? What happens when we square something? It becomes positive. But you have to make sure you type it in the right way, because if you type it in like this, your calculator thinks you're saying that. So you got to make sure you use parentheses. So don't forget, use parentheses, put the exponent on the outside. But if it has an odd exponent, it's going to stay the same sign it is. If it has an even exponent, it's always going to be positive. All right, write down problem number 4. Now this one is neat because it has that 0 power in there, which is the first rule. Anything to the 0 power is 1. What is being raised to the 0 power? Just x. Is the 9 being raised to that power? No. So this becomes 9 times 1 times y to the 5th, or just 9y to the 5th. Anything with a 0 power becomes a 1, and it's going to just multiply all the other things that are there. Okay, write down question 5. It is. Why is it just 1? Yeah, the 0 power would be shared with everything, and anything to the 0 power is 1. So this whole answer would be 1. So if you have those parentheses with a 0, the whole thing's 1. But the other problem, just the x was 1. Move this up a little bit so you guys can see better. What are you thinking about with number 6? What's wrong with it? So what do we do with the negative? Yeah, but what about the x? It's going to go on top. You're exactly right. The x to the third is going to stay on the top, but on the bottom we're going to have y to the 2nd. So that negative exponent goes away. So only move the variable that has the negative exponent. The positive exponent is going to stay wherever it's at. All right, then we got our last one here. Write this one down. Bless you. Now remember, we can only work with the things that are alike, right? So this 4 right here is a whole number. It is like this 12, that's a whole number. Those two things are not exponents, so we don't subtract them. If there was just a 4 and a 12 there, what would you do with them? Divide them, simplify them. That's right. Those are the things that you want to do. So what is 4 over 12? 1/3. So 1/3. That just simplifies there to 1/3. What about x to the third over x? X to the 2nd on the top or bottom? Top. What about y to the 6th over y to the 2nd? on the good. And that's it. So treat each piece as one part at a time. But if you have nice whole numbers, do whatever it says. If they're in parentheses, you're going to multiply them. If they're on top and bottom of a fraction, you're going to divide them or reduce them. Now, you don't really need that 1 up there, so if you wanted to make it look prettier, it's x squared y to the 4th all over 3. You can keep it like that. Also, keep your divide lines when you do fractions, keep them horizontal instead of slanted, just to make sure we have the right stuff in the numerator and denominator. Okay, that was a good review of exponents. How do you feel about exponents? Better? Oh, that's better. All right, so let's do some exponential equation stuff. This is going to pop up in a second, but you guys can go ahead and write it down. This is our exponential equation. We wrote this down the second day of school. There it is. Exponential equation or graph. It's fine. So write down all of this stuff, and then we'll do those 3 little problems at the bottom. Sure. Yeah, just sketch the graphs real quick. You don't have to put any numbers on the graphs, just wanted to show you what they look like. Okay, so exponential graphs or functions are in the form y equals ab to the x. So that's like your standard form. That's what you start with. A is your initial value. It's often the y-intercept, but we're seeing a little bit it's not always the y-intercept. B tells us if you have a growth or a decay. So if B is greater than 1, it's considered a growth. And if B is less than 1, then it's considered a decay. You will never have a B value that is negative. That gives you some weird answers. So there won't be anything 0 or negative numbers. I didn't include that in here because you won't see them. And we'll talk about it a little bit more tomorrow when we do some word problems. So these are two different graphs that we have up here. Our exponential growth graph, it levels off but then grows really quickly. And our decay decreases rapidly and then levels off. The graphs will always level off at some point. So what I want us to do for these three problems is just say if it is a growth or a decay. So remember that part is B. When you look at this equation, where is B? It's in the parentheses. That's right. That's where B is going to be for all of these. And B is always being raised to the x power. So what's being raised to the power here? 0.26. What about this one? And then this one? 1/2. So remember, any number that's more than 1 is a growth. Any number that's less than 1 is a decay. So what are we going to say for this one? Decay. 0.26 is less than 1. This one? Growth. And the last one? Decay. Now, just because it's a fraction, does that mean it's always a decay? No, be careful. Make sure that fraction is less than 1. So anything between 0 and 1 is going to be decay. Anything more than 1 is going to be a growth. Tori, just save some space. I'll let you copy these down later, okay? So we can finish some notes. Oh, you got it? Okay, good. You copied fast. All right, let's do some graphing. So everybody go to your graph paper and write down this first equation. We are going to sketch a graph and identify the horizontal asymptote. It sounds funny, y'all. Look up. The horizontal asymptote is an imaginary horizontal line that the graph doesn't cross or touch. We can just call it HA if you want to. When we do these graphs, you only need to do 1 point for me to make these graphs. The only point that I'm going to be looking for is your y-intercept. And then I want you to make sure, is it graph the correct direction? Is it a growth or is it a decay? So when you see a regular equation, pick out those two things. I want you to pick out A and B. So what is A in this problem? 2, and B would be 0.3. Those things will help you make your graph. Now, a lot of times before we make a graph on paper, we probably need to check to see what it looks like on the calculator. So let's do that with this problem. So go to y equals and type it in exactly how it looks. Remember to use the caret key right there to get that exponent. Your graphs may be all mixed up from the other day, so how do we get it back to our standard graphs? Anybody remember? Good, zoom 6. Okay, so what do you notice about this graph? It's decaying. Do you notice anything about the y-intercept? It intersects at 2, which was the same as our A value. What else do you notice as the graph continues to the right? What happens? It gets closer and closer to that x-axis. So on this particular problem, our x-axis is our horizontal asymptote. It's the horizontal line that the graph will not cross or touch. It's kind of like, I don't remember that little fable that you have, but if you have a distance, you can cut that distance in half and in half and in half. But because numbers are infinite, you can keep cutting it in half and it will never touch that part, right? Because you could keep going and going and get the tiniest little measurement. So that's what happens with these graphs. So if we were to graph this, only point I need is the y-intercept. So my y-intercept's at 2. And it is a decay. So you're going to start up high and then level off at that x-axis. So the other thing I want us to identify is that horizontal asymptote, and you can call it HA if you would like to. Now, HA is the x-axis, but we want to say it as a line. So our horizontal lines, x equals or y equals? Y equals. Horizontals are y equals. What would y equal at this point for being the x-axis? 0. So this horizontal asymptote is at y equals 0. Well, we're going to see another example a little later on, but it's where the graph levels off. So it levels off at this x-axis, and what are the y values for the x-axis? Like, yep, they're all 0. So that's why it's y equals 0. All right, write down part B. Now, when we get started on this one, we want to pick out A and B. A and B are both numbers that you might can tell from the problem. But in this case, we only have the number 2. Is that one the A or the B? Well, remember, B is being raised to the power. So what's being raised to the power? B, which is 2. So what is A? If it's not there, it's an imaginary 1. That's right, because it has to be times. So if you need to, write that below. It's actually 1 times 2 to the x. And we could do the same thing on our calculator. We could go back over here, go to y equals, and graph 2 to the x. And what do you notice about that graph? It's a growth, and also what else? It crosses at the 1. So the 1 is coming from this number at the beginning. And the 2 is telling us that we have a growth. So we're going to start close to that x-axis again. Because if you look at that graph, that horizontal asymptote is our x-axis. And then this part is going to increase. So we're going to start out hugging that x-axis, go through a y-intercept of 1, and then jump up. And then there's part C. Here's our next one to graph. This one's a bit different. What does it have that's different? It's got a -6 at the end. That reminds me of something that we've talked about. What happens if there's a -6 at the end? It goes, not right, but at the end, down. That's it. If this one is a minus at the end, it's going to make the graph move up and down. So what happens is the graph moves down 6. So what's going to happen with our horizontal asymptote that we had? It's going to go down 6. So when you first start making this graph, that horizontal asymptote is going to be at y equals -6 because we went down 6. So this is what I like to do because it's an imaginary line that our graph won't touch or cross. We need to put that on our graph, but put it as a dotted line. So go down 1, 2, 3, 4, 5, 6, and make that dotted line. So that's your horizontal asymptote, kind of like your new x-axis. That's the imaginary line that this graph won't touch or cross. So these problems didn't have anything added or subtracted at the end, so our horizontal asymptote was just y equals 0. It was just that x-axis. But if you have something added or subtracted, it's going to move that whole graph. It's going to shift it. Okay, so what is A in this problem? 2, and B is 4. Now, 2 is telling us the y-intercept. But what happened to the graph? The whole thing shifted down 6. So it's actually 2 above that line equals 6. So where's my y-intercept at? -4. So keep that in mind as you're doing the problem. Because it shifted down 6, it changes your y-intercept. B equals 4 is telling us that we have a growth. So the only thing B tells us is it a growth or a decay? So we're going to start close to this dotted line. Then we're going to go through that y-intercept of -4 and then make our graph. Can you also graph this on the calculator to double check? Sure. Yep. And I'm going to do that real quick so that way you guys can see it as you're finishing your graph up. So it was 2, 4 to the x. And then don't forget to right arrow to get that -6. The -6 is not in the exponent. It's at the end. And then our hit graph. So you can see that it kind of levels off. And you can see that y-intercept is at -4. You can also hit trace. If you hit trace, you get x equals 0. So if x is 0, then we have our y-intercept. You could go to your table, find where x is 0, and it gives you your y-intercept. If I tell you to graph this on a test, the 3 things that I'm going to look for are the y-intercept, is it put in the right place? I'm going to be looking for your dotted line or where it levels off, so make sure that it levels off the right spot. And then I'm going to be looking for, is it a growth or a decay? So what's an easy way, if you had to explain this to somebody, how to graph one of these? Let me just give you a random example. You don't have to write this down. Give me some numbers, you guys. 6, 1/7. One more number. Okay. I want to go plus. But how would you tell somebody how to graph this? You draw a dotted horizontal line at y equals 2. Good. Then you go above that dotted line 6. Good. And make a dot. That's your y-intercept. Okay. And then what? You draw a decaying graph. And remember, it's going to get close to that dotted line but not touch it. Very good. So horizontal asymptotes, y-intercept along with that horizontal asymptote. You've got to put those together. And then look at this number for growth or decay. Muy bien, la clase. Every now and then I speak Spanish. You don't have to write these down. I have these printed for you. So that way you don't have to try to draw these graphs. We're going to do these examples, and then we have another one to do. Okay, so here our first problem says that we have the function 3 times 1/2 to the x, and it is replaced with f of x plus k. So what it's telling us is that we have some kind of translation here of going up or down. Because if you notice, this graph should cross, or this function should cross the graph where? It should cross the y-axis at 3. Does this graph cross at 3? No. Because of this number here, we should have a y-intercept at 3. Where is this y-intercept? -6. So our graph got shifted down. How much did it shift from here to here? 9. Our graph shifted down 9. So what should have been at the end of our graph? -9, because it shifted down 9. So the value of k is -9. So a quick way to do it is look for those y-intercepts. All right, let's look at our second problem over here. 4 y'all's is at the bottom. It says the function 2 to the x was replaced with the same thing, so now we see this graph. So if you have this function 2 to the x, What is the y-intercept of 2 to the x? We just graphed this one too. It's 1. That's right. Does this graph have a y-intercept of 1? No. It went which way? Down. So our k value is going to be negative. How much did it go down? Down 4. 1, 2, 3, 4. Yep. So the k value would be negative 4. All right. Flip it over to the back. Yeah. Remember, it's y equals ab to the x. So this one would be 1 times 2 to the x. The 2 is the b. All right, on the back, we have this problem here. The function is 3 times 4 to the x. Same question again. What is the y-intercept of this function? 3. Does this graph start at 3? It went which way? So what's the value of k? Negative 1. Now, I did 3 examples of where they go down. That's probably not good on my part, but sometimes it can move up. So if it moves up, just make that k value positive. All right, one more graph type problem. It says we have 2 functions here. F of x and g of x are shown. Which one has the higher y-intercept? Well, with the graph, we could quickly tell the y-intercept is at what? Negative 3. Yep. So this graph has a y-intercept at negative 3. With the function, we have to figure out the y-intercept. Now, you could look at a table, you could look at a graph, but how could you find it just by looking at the equation? Well, what do we know about the equation? It's going to go down 7. This tells us it moves down 7. And then it would be 1 above that because of this number here. We have an imaginary 1. So then it would be up 1 from that line. So if we go down to negative 7 and then we go up 1, where are we at? Negative 6. So this one has a y-intercept at negative 6. Now, if you don't like you doing the algebra way, we can do it with our... So type it in y equals. Everybody do this with me so that way we remember how to do it. Type in that equation exactly how it looks. 2 to the x. Don't forget to right arrow. And put your minus 7. You don't even have to look at the graph, but if you want to, you can. You can hit graph and you can start counting. And it looks like it crosses at negative 6. To confirm, trace 0, enter. When x is 0, that gives you the y-intercept. Or just go to your table. You didn't even have to look at the graph. When x is 0, y is negative 6. So this one has a y-intercept at negative 6. One way to do this problem too is to find your y-intercept. Here's a little hint that you can use, I guess. The y-intercept is the a plus k. If you remember the k from the other 3 problems it talked about, figure out the value of a, add or subtract k to it. So in this case, it would be 1 minus 7, which would give us that negative 6. And that's how we would use that hint. So the 1 is here, the negative 7 is here. Add them up together, you get your y-intercept. All right, one last thing that we're going to do is we're going to write equations given 2 points, and then you guys will have some homework to do. So far, has this been hard work to do? And if we get confused, where do we look first? Our notes, and then me. All right, so write these 2 things down. Write that sentence down so you know what problems you're working with. Now this one wants us to write an exponential equation given those points. So if you look back at the beginning of your notes, an exponential equation is like y equals ab to the x. We're not going to worry about any shift going up or down. No, none of the horizontal asymptotes. We're just going to write the basic one. So if we are given coordinate points, these are what type of values? X and y. This is an x and a y, and this is an x and a y. Now, we need to figure out what a and b are, but we can use x and y to help us figure that out. So the first thing I'm going to do is I'm going to plug this point in for x and y. Then I'm going to plug the next point in for my x and my y. Now I have two equations with two unknowns, and I'm going to use a little substitution to help us figure out what those values are. So all the things that we do in Math 3, they just pop up again and again and again and again. But I'm going to give you some hints over here. So your first step is to plug in for x and y. And then your second step is to solve for a. So you can solve either one, but it's usually easier to start with that first one. So Carter, what would we do to solve this one for a? Well, what's happening with a? It's being what? So the opposite of multiply is to divide. So a equals 2 over b squared. Step 3 is going to be to substitute. So I'm going to take what a equals and I'm going to put it into the other equation. So I have 4 equals 2 over b squared times b to the third. Now we can solve for b. So the first thing that you want to do is look at multiplying these together. Now if you have a fraction times a whole number, you can take that fraction and put it over 1 and then multiply the tops and the bottoms. So this would be 2b to the third over b squared. Straight across the top, straight across the bottom. Now simplify. If there's a power over a power, you subtract. So what's 3 minus 2? 1. So now this is a very simple problem, right? B to the first or just B. What would you do to get B by itself? So B equals 2. Now I know this can be a little confusing sometimes. That's why I got a second one to do. So just keep following along. Keep writing it down. And I guarantee on the second one it'll make more sense. What do you think we do after we find B? Plug it back in and solve for A. So I'm going to plug it just back into this equation right here where we went ahead and solved for A. That to me looks a little bit easier. So this is 2 over 2 squared equals A. Or what is 2 squared? 4. And what is 2 divided by 4? 1/2. Now I have A and I have B. So my last step is to write the equation. So my final answer here would be y equals 1/2 times 2 to the x. So the b always goes in the parentheses with the exponent on that outside. Can I multiply, I didn't talk about this yet, but can I multiply 1/2 times 2? If you think about order of operations, we do what first? Parentheses, then exponents, then multiply. So can I multiply these together if that has an exponent on it? No, cannot. All right, let's try part B over here. We're going to do the same steps. You guys help me out and make sure we got it right. So what is the first thing that we want to do on part B? Plug it in x and y. So what's my equation going to look like? To the second. So we're plugging in for the x and the y. So 4 equals ab to the second. Then plug it in for the other equation. What's that going to be? Now what's the next step? Solve for a. So let's just solve this first one for a. What would you do to get a by itself? So 4 over b to the second equals a. We just divide that b to the second, get a by itself, and then we plug it into the other equation. Good, we make that substitution. Then how do we write the answer? Or b to the third over b squared. Yep, you go ahead and multiply those together and then simplify. 3 minus 2 is? It works out really nicely when your x values are 3 and 2. They're not always 3 and 2 though. So just keep writing it out like we've done and think about what you need to do to simplify. But the exponents are 3 and 2. We can just subtract them. We get b by itself. So b would equal 4. So now we've solved for b. So now we need to plug it in the other equation and solve for a. So 4 over 4 squared equals a. Well, what's 4 squared? 16. And that can reduce to 1/4. I tried to pick similar problems so that way y'all would have good examples in your notes. Don't forget to write your final answer as the equation. Y equals ab to the x. But you might have different numbers when it's time to do your homework. So just look at what you have. Follow the steps. Go through and simplify. All right, your homework is this worksheet. There's 2 problems like this. They're on the back side. I did put there more problems on the back because there's only one. So if you want to do those first because they're the harder ones, you can get those over with. There are 6 problems in the middle where you have to graph. So graph those on graph paper. So you can write on this worksheet, but you'll have to staple your graph paper to it when you turn it in.